Right, so I'm going to start off uh, going over the transpiler as like an overview and go over some of the benefits, and then transition into some actual live demos. If anybody has any questions along the way, please don't hesitate to like raise your hand in the Zoom call and ask those in real time. Otherwise, I'll also be taking more questions at the end as well. So there we go. All right, so the transpiler. What is the transpiler? If you ask Wikipedia, it's a type of translator that takes source code from a program written in a programming language as its inputs, and then produces an equivalent source code in a different programming language. As it relates to MTConnect, more or less, it is taking SysML, turning it into a C# object, and then converting that object into basically anything else. And that's a lot of what I'll be kind of showcasing throughout this presentation. Furthering what is a transpiler? Transpiler is kind of broken out into two separate parts of an architecture. There's the C# software development kit, which is the MTConnect.transpiler. You can find this project on GitHub, as well as you can download it on NuGet. And then the second half is the sync architecture. So we've implemented a series of syncs that enable software developers to more quickly develop transpilers that can produce things like C# files, JSON schema files, and basically any other type of file using Scriven templates. Who should use the transpiler? Basically, developers. Developers are really the sole audience for the transpiler. This includes adapter developers, agent developers, anybody that wants to make a machine monitoring application, anybody that wants to make a tool surrounding MTConnect. The transpiler is an invaluable tool to help you kickstart that development. Some use cases with regards to uses of the transpiler can include code generation. This is probably the primary use case for using a transpiler. If you want to create code that is synchronized with the keep clicking buttons. If you want to write code that is synchronized with the SysML model, which is what the standard is written as, then you can use the transpiler to convert that representation of the standard into whatever code you want. As you're dynamically generating this code, you can also dynamically generate documentation that's also synonymous with the terminology that's used in the standard. So this is helpful when you're developing, additional SDKs. It provides additional context in developers' IDEs so that they have more context into what they're actually writing. And I'll showcase this later on in the demos. This also provides a great opportunity for continuous integration and continuous deployments. So we can easily create workflows that are triggered based off of updates to the standard. And those workflows can then automatically generate the code that you need for your software. So you can truly have a continuous integration with MTConnect, directly related to the release schedule of MTConnect. Additional use cases include documentation. So the transpiler by nature starts off with converting the SysML model into C# objects, but from there you can create really whatever you want. So theoretically, you could write documentation for the standard. You could write your own documentation. We're also looking into using the transpiler specifically as a potential opportunity to rewrite the model browser in the future, or at least elements of it. So right now there's like a custom transpiler, if you will, that generates or regenerates a lot of the site that you find on the model.mtconnect.org. So again, we're just highlighting that you can basically create, whatever format you want out of the SysML model, whether it be PDF, HTML, text file, rich text file, yeah, whatever you want. Additional use cases, these are more like ancillary benefits to code generation. There's already a few utilities that are out there for aiding in the development or implementation of MTConnect. These three examples I'm personally involved in, but I know that there's others out there. TrackHound is one that uses the transpiler to develop their SDK. So these three options here in the MTConnect Adapter SDK, this is a model-aware approach to developing MTConnect compliant adapters, and I'm going to demo this towards the end, this segment. But this is a way for adapter developers to make sure that the data that they're outputting to an agent is MTConnect compliant to begin with. MTConnect Core is another project that's open source. This is a project that's aimed at helping new developers within the MTConnect space get a head start in consuming MTConnect from an agent. So it basically deserializes any of the responses from the MTConnect agent. There's a lot of built-in validation in there as well. All of those basic validation rules and the enumerations of what values are appropriate for execution, all the enum type of values, what are appropriate values for units, types, subtypes, all that is automatically generated using the transpiler. So, and then that the MTConnect core is actually used in the online MTConnect validator, which I forgot to add a link. I'm actually going to be demoing that online MTConnect validator in a later segment today. So I'll go into more detail then. All right, now we're going to talk about the impact of some of these developments. So the MTConnect Adapter SDK, being that it's a model-aware approach to developing adapters, is only realistically possible through code generation. So being able to maintain the explicit definitions of values for the enumerable types and component structures, and just having representations of every single observation type within MTConnect is a daunting task as a developer. I did that originally with the MTConnect core project, pouring through the PDF files, looking at the previous version and then looking at the current version and figuring out what the differences were, and trying to maintain that manually and have a good code base, good clean SDK. It took probably about 2 weeks just to do a basic implementation of the changes from one version to the next. So similarly with the adapter SDK, like a lot of the same principles apply. Like we have to have a comprehensive list of all the data item types and subtypes and all the values. It's unrealistic to maintain that manually. Going further into the benefits of the adapter SDK specifically is that you get to fluently describe your device and the types of data items that you want to publish in a way that's natural for the developer. It also allows people that are unfamiliar with MTConnect to essentially kind of browse the standard through code, and I'll go into that again with the demo shortly. MTConnect core, I touched on this as well, but again, it's a model-aware library. It was really only possible to maintain this project long-term with the help of the transpiler. And actually, this project is what inspired me to help start up the transpiler project, because it was so much of a manual effort to maintain that library and provide something like validation. Um, yeah, the automatic code generation is, invaluable tool here. But yeah, so this library again is capable of communicating with the agent, performing those REST protocol requests for probe, current, sample. It also handles intervals. Again, it's a really great project, especially if you're a researcher looking to just get started with MTConnect. This project, or this library, again, open source, is a great head start into just, I have an agent or I have a machine that communicates MTConnect. Let's see what I can do with this data. And then the online validator, again, it references the MTConnect core library to help perform validation. But this is a extremely impactful tool, at least for our company, and I know several other users of this tool that are implementers. They're able to much quicker validate their implementations before they ship it out. And for us, when we're installing new devices at a shop, we're able to validate that in real time before we even leave the door. We can make sure that the device configuration file for the agent is appropriate. We can make sure that we turn off any errant observation values or data items before we even leave. And that was a big problem in the first couple of years of our company. Is you get an adapter online and the data integrity is horrible. So a week, 2 weeks later, we got the customer calling us and they're complaining that these dashboards don't look right. Well, it turns out that the adapter didn't spit out the data correctly. It was incorrectly spitting out execution state as a number instead of a string value that actually followed the standard. So data integrity, it's a real problem when it comes to actually using MTConnect, and this validator was our way of kind of covering ourselves and being more proactive up front and making sure that we're not going to have issues a week or a month from now. And that goes into the incompatibility of the monitoring systems. So if you are trying to, as a machine shop, if you're trying to implement a machine monitoring system that maybe heavily relies on the standard, like it strictly references execution states active and ready, and let's say that it's incapable of handling those invalid values, like a numeric value of 0. Again, this is where the validator can help proactively prevent these kind of software crashes. So you can have more of a heads up that these issues are going to arise. Again, this online validator is based on the MTConnect core library, which is only possible through transpilation. Okay, so now we're going to go into more of the architecture of implementing a transpiler. So I'll reiterate here that the MTConnect.transpiler project and NuGet package, that library is capable of deserializing the XMI output of the SysML model into a C# object. So when we publish the standard, we publish this XMI file, which is like an XML document. And this is a full representation of the current SysML model. So it has all the definitions of all the observation types, the enumerable values, when things were introduced, when they were deprecated. There's all sorts of information, basically all of the information about MTConnect in this one file. So I had mentioned previously that there's a sync component. So the transpiler is capable of consuming that XMI, converting it into a C# object. The sync part then takes that C# object and allows a developer to do with what they will. But they essentially will be expected to navigate that C# object and find the components of the SysML model that they want to write, to some sort of output media. And then they're responsible for writing that media. This is all open source as well, but you can kind of see the various workflow of the transpiler, where we go from the SysML XMI, goes into the transpiler for deserialization, which then gets converted into an object-oriented model. And then that model gets sent to a sync, and the sync is expected to do anything it wants. So how do you use a sync? There's some examples online. I've been slowly trying to build out some additional documentation, specifically on the MTCup site. There's a new page, MTConnect dash transpiler, which, let's see. There you go. So if you go to MTCup site, this MTConnect transpiler page is actually pretty comprehensive with a lot of what we're discussing here. It also has a lot of links to examples of how to use the transpiler, how to develop a sync in an abstract way, how to reuse other people's syncs. And again, I'll go into a live demo here shortly. But so the general workflow here is that to create a new sync to write files using the transpiler, is most likely you're going to want to create a console application, but really you could create a web application. It doesn't matter what type really, but the most common is going to be console application. And this is something that can be helpful when you are trying to implement like a continuous integration workflow, because these types of applications can be triggered within those workflows, and they're pretty lightweight. The next thing you want to do is, in the case of implementing like a C# sync, if you want to write C# code, is you'll want to implement a Scriven template model, and there's examples for that here in the Adapter SDK and MTConnect core, where you'll basically want to define a model that can be used in the templates to output your files. And then you'll implement a transpiler class, which is an implementation of the transpiler sync. So this is what the transpiler will use to send the model to for you to do whatever you want. In the case of using the C# sync, you're actually going to override that because there's a lot of helper classes in there to streamline the output of C# specifically. Okay. So I'm going to back out of this PowerPoint and go into a live example of how to write a really basic transpiler. I'll pull Visual Studio. And so I've got this project or the solution, and this is posted on GitHub. So we'll provide a link for reference if anybody wants to dig into this further, or if they want to follow along later. But basically what we're going to do is as part of our goals, our end goal is we want to create a text file with just simply a list of all of the observation types in MTConnect. So these are things like availability, execution, path feeder, override, like all these types. I just want to put all of those in a text file. So how do I do that? Well, first off, we're going to start by adding the NuGet package. We're going to look for MTConnect transpiler. There it is. And I'm actually going to choose the pre-release right now because this is the one that's compatible with 2.3. Once we officially release this, then we'll release the full version. With that package installed, I'm going to go ahead and add a new file called my transpiler. So this is going to be what the class that actually implements the transpiler sync for us to consume that model and start writing things. So to start off, I'm going to want to implement the iTranspiler sync. So when I fully implement that, you'll see that there's a simple transpile method, transpile method, and the first parameter here is the deserialized model of SysML. Now, what I'm going to want to do here, like from here, is navigate the model. So again, going back to our goals, I want to find all the observation types. And observation types are broken down in the SysML model by categories. So events, samples, conditions. So instead of me having to kind of copy and paste code, I'm actually going to do this a little bit programmatically. So I'm going to define a list of categories. Events, conditions, and then I'm going to iterate through each of these categories. And as I'm iterating through, now I'm going to want to navigate the model to find where these observation types are for each category. So as I iterate through sample, I want to find all of the sample observation types. So I'll go ahead and define a new variable here. And I'm going to use a helper class that's part of the transpiler. So the MTConnect helper class has some navigation methods that kind of help you jump from area to area within the SysML model. So in this case, we're going to jump to package. We're going to provide the model explicitly. And then again, we're going to use the MTConnect helper class to help tell this method what the navigation path should be. So if anybody has actually looked at the XMI output for SysML, it is extremely complicated. There's a lot of jumping around from package to package. You might be saying, what is a package? But it's basically, think of it like a website, or like look at it like the model browser for MTConnect. There's the tree view off on the left side, and you're basically having to navigate layer by layer to the part of the standard that you want to review in the model browser. So it's the same concept here. We're going to have to navigate our way down to the section of the standard that contains these types. So again, we're going to use the MTConnect helper class or static class to help navigate us down to the level of the observation types for sample. So to do that, we're going to start off with the package navigation tree. So this is a dynamically generated class structure to be used as like a shortcut to reference the navigation tree. So this is an object-oriented approach to kind of browsing the SysML model. You can go through here, you can explore, kind of play around with what packages are available, but we're actually going to jump straight into the observation information model and then observation types. That's where all of the observation types are. And then we're presented with a package. In this case, I know that there's a subset of packages within observation types that I want. I'll go ahead and reference that full list of sub packages. And I'm going to find the first one where the name of the package is the name of the category and just simply types. I help to do the comparison. So this ultimately will point to string called sample types. Now that I have this package, all of the observation types are represented as classes in the XMI model from SysML. So I'm going to iterate through each of the classes in this package, and this should get me each sample event condition type. Okay, so I finally made it to the point where I can access all the observation types. So I'm going to go back up here and create my text builder. This is what's going to help me create the text file. I'm going to go back into the for each loop and create a new line for each one of these observation types. And I'm actually going to preface each one with a reference to the category. We're going to make it more of like a CSV. And then we're just going to grab the name of that observation type. Simple as that. And then to close out our goal, we're just going to write everything to a file. We don't currently have a reference to the file path, so I'm just going to create a constructor here. And now when we initialize this transpiler, we'll have a reference to the output path, and we'll just simply output it there. Okay. So this is a really, really basic implementation of a transpiler. We're going to go back to the main program here to actually do the live demo here of what we just wrote. So I'm going to define some constants here to help me out. But these are going to basically just define the location of the SysML model. I happen to know exactly where that is on my file system. And then we're going to define another constant for the location that we want to save this text file to. Okay. So now we're going to get into firing up the transpiler and then providing it this sync and then running the transpiler to generate that sync. So in order to fire up the transpiler, we're going to create a set of options for how we're going to provide the model to the transpiler. So in this case, the transpiler provides a couple different options. For this demo, we're going to use the from file options. So this is going to help us define exactly where a copy of the system model lives on a local file system. There's other options from GitHub. I wouldn't recommend using this right now because we don't have a continuous integration with the release schedule of MTConnect standard to create a release on GitHub. So as soon as we do that, then this option will essentially give you the latest public release. Alternatively, I know that the model browser actually has a copy of the latest release, but I think the file name is inconsistent on there. So I haven't created an automated method for that. So once we have the option defined here, again, we've pointed to a specific file path. We're going to fire up the dispatcher for the transpiler. So this is a transpiler dispatcher. We're providing it the options that we just created. And then the next step is we're going to add the sync that we just created as well, the my transpiler. So I'll initialize the new my transpiler, provided the generated path. So that's the one string that we added to the constructor. And then with that new instance of my transpiler, we're actually ready to go ahead and transpile. And then what this method is doing in the background is it's loading this sysml file. Once it's fully loaded and deserialized that XMI document, it's going to provide that deserialized object to my transpiler through that transpile method. I'm going to go ahead and have an indicator that everything's done. And we're just going to wait for input. Right. So now we'll go ahead and run this. And it should output to a folder right here. So right now this folder just has the XML document that represents the standard. When we run this, it should create an output.txt file. Done. And we see the file. Open this up. And just like we formatted, we have the category, comma, and then the observation type. And it's all of the observation types. So events and then conditions. Okay. So that is the example for starting a really basic transpiler. As I mentioned, we have other projects that are open source that implement transpilers. They're obviously more complicated transpilers. And if we look at, for example, the adapter SDK, I've created, again, a console application that generates these files for the adapter. And what that looks like is it's basically an implementation of the C# transpiler. So it's a sync, it's an abstract sync that's dedicated to aiding developers in generating C# files. And what that sync requires is, again, I mentioned it in the PowerPoint, but there's not great examples in there. But you basically just define a class structure or models for your Scriven templates. And Scriven is another open source library that you can use to develop templated files. So in this case, we have the model for Scriven, and then we have a folder full of these text files, essentially, that follow the Scriven template guidelines. And these models that we created get provided to these template engines to then generate. Anyway, if you can kind of read in between the lines, it generates C# code. In this case, for the adapter. It's specific code for the architecture that we've developed for the adapter. So when we run this transpiler, basically whenever the standard is updated, we end up with a lot of, like enums automatically generated. So all of these enum values and enum types get automatically generated by the transpiler. And it creates nice clean code, fully documented with synonymous with the model browser. So when you actually navigate the adapter SDK, you can actually click into the model browser to review acceleration subtypes. We also introduced a lot of versioning. This is all generated from the SysML model, but we can automatically generate references to when things were introduced, as well as when they were deprecated. I don't know if I can go to event types. There's a lot of deprecated examples. So here, alarm, deprecated in 1.1. Again, these attributes were completely automatically generated from those script and templates with the aid of the transpiler. Let's see, I'm going to quickly double check the comments because I've got another demo of the adapter SDK that I'll do to kind of go into how the transpiled code kind of looks in use. All right, it's just Will. Okay, just Will. Okay, so I'm going to go back into our demo day project here, into the adapter project, and we're going to go into developing a brand new adapter, just a random adapter, and kind of explore what that transpiled code looks like and how this adapter SDK at large can really help new developers into MTConnect create a compliant adapter source. Okay, so going into the main program here for the adapter, we have a couple different goal items here. We need to create a device model that represents the device that we want to publish data for. We need to create an adapter source. This is the mechanism for which that model gets populated. And then within that source, we need to randomly change properties of that device model. And then here in our main program, we already have some pre-written code to start and run the adapter. There's also some additional code here that I have PuTTY installed. So we're going to prompt, when we run the program, we're going to prompt the user to run PuTTY and view that stream of the adapter data. Okay, so the first thing we're going to do is we're going to create a new class. Or wait, let's see. Actually, we're gonna add a new package, and this is going to be the core for the adapter SDK. So this is all you need to create a data model. And if you already have a project that implements the TCP adapter, then the adapter SDK core is all you need. So that's all that we need right now. We're going to install that. And now we're going to create that data model class. We're actually going to make this public so we can discover it in the adapter. And what we're going to do when we're defining device models is simply implement the iAdapter data model. So this is an indication to the adapter that, hey, this is a device model that you can reflect upon and output through the TCP adapter. So according to the standard, every implementation has to start off with availability. So if I actually create a strongly typed property here based on the standard, I can do that. So I'm actually going to reference the transpiled class for availability. Okay. And if I want the adapter to output this property to through the stream, I want to decorate it with the appropriate attribute. So in this case, I want to indicate that this is an event category type. I'm going to provide it with a name and a description. And we have a broker reference. So I want to make sure that specifically for event, you commonly end up with this kind of confusing using, but it's going to be the MTConnect adapter SDK attributes. This doesn't necessarily happen as easily with samples and conditions. There's not overlapping attributes. We're also going to throw in some random extended data items here. So I'm just going to add a random X and a random Y. So, I mean, for an actual implementation, this could be, path position or the current position, whatever you need. So we're going to describe that as X. This is for X. Copy that. Okay. So really, really basic device model. We're utilizing one of the properties from the transpiled code. The next step is to create a source. So how do we get data from quote unquote the machine into this model, and then this model up to via TCP, right? Communicating with an agent. But for this, we're going to create a source. And this time we're going to implement the iAdapter source. Okay. We're actually going to implement that. You'll see it creates a bunch of these properties. These are more or less just kind of shortcuts to help pass data along to the agent. They are completely optional. It's okay to throw an exception here. By default, there's exception handling in the adapter in case these aren't provided. Some other elements to what's being implemented here is some event handlers. These basically just help the upper level of the adapter just know what's going on. I'm going to wrap this in a region so that we can kind of hide it, things up a little bit. Okay. The other two methods here are the start and stop for the adapter. So this is where you're going to want to actually begin your communication with a device. In this case, we're just going to set up a timer. So I'm going to then in the start method, I'll go ahead and initialize all that. At the interval, in this case, I'm just going to do it every half second. And then when we start the adapter, I want to start the timer. Move this out of the region. And then when we stop the adapter, I want it to stop the timer. Okay, simple. And now when the timer elapses, what are we going to do? We're going to want to update the model. Well, we need to create a reference to the model. So we'll do that here. Now, whenever the timer elapses, we can go ahead and reference that model. And in this case, I basically just want to randomly change values in the model. So I've created a random data helper here to help me facilitate that. And we're going to be using, again, the transpiled code in the adapter SDK. There's a full list of availability values. So I'm just going to create an array of the available options. I'm going to hard code those here. So I've got a string array for available versus unavailable. And then the same thing I'm going to do for X and Y. I'm going to use the random data helper to just randomly give me numbers. Okay, so this just simulates, I have a connection to a device. Maybe I use an API or another SDK to help me communicate with that device. And I go and pull that API or that device in some way. And when I'm pulling it, I can update my model any which way I want. At the end of this event, I basically want to use this on data received event. I want to trigger it and provide it this source and a reference to the updated model. Okay. So now every time this timer elapses, I will basically send the TCP adapter that we initialized in the main program. I will send that model to the TCP adapter to then send through the TCP stream. Okay, so the last to do here is to just simply start the adapter, and I need to provide a new reference to the adapter source. So that source that we just created in the demo model, which I'm going to create a new file, break that out. So this source we referenced in the main program, we're just providing it to the adapter when we start it. And as this adapter is starting, it's going to call that start method in our implementation, which is going to start the timer. So if I go ahead and run this, okay, it says the adapter is running at that port. I'm going to go ahead and open up PuTTY. And we're starting to get the data every half second. You'll see here that it's flipping back and forth between available and unavailable. I'm going to go back into our code and just go back to the model real quick as I'm closing this out and highlight just the availability of all of the transpiled code. So if we navigate through the namespaces here and look at data item values, you'll see here that there's classes here for every single observation type. So if you want, execution state, you can reference execution state. If you want to explicitly use the terminology in MTConnect, you can easily do that by referencing these subclasses. So there's all sorts of like implicit operators within this dynamically generated within these classes that were generated by the transpiler to ease the development of your adapter. And it's all using the correct terminology It's defined in the standard. So there's examples on GitHub for the adapter SDK. So the adapter SDK repo has some documentation in the initial README, and then the wiki also has a lot of documentation on how to use this, how to set up a device model, how to set up very complex device models with component structures. And then there's also True Analytics has a PC adapter. This is a really good tool to demo the SDK as well as MTConnect. So this PC adapter, when you run it, there's a console program, the terminal. When you run that, it's just going to track your mouse movement and like what active window is open, and it puts it in terms of MTConnect, and then publishes it via TCP like you saw in the PuTTY session. All right. I think I just about ate up the whole hour there. So the last couple of minutes, I'll take any questions.
Anybody has a question, you can come off mute and ask or raise your hand. Trey, I had 3 questions that people had typed in for me. So the first question was, can you go over the pieces that are licensed versus open?
Sorry, say that again.
Can you go over the pieces that are licensed versus open, which I realize you already presented in here, but could you summarize that again?
Yep. So the transpiler is under the same Apache 2 license as a lot of the other projects on MTConnect. The adapter, I believe the adapter SDK is also Apache 2. But everything that I've shown you so far is open source. Does that help?
Yeah, I think so. That was an anonymous question. The next one was, can you talk about which pieces of the transpiler are a plugin, which pieces are native to the agent, and which pieces are separate?
Okay. So the transpiler, let me get my bearings here. If we go to the MTCup site, I've added a section here for syncs, and then there's also examples down at the bottom of the page. Right now, all that we provided within the Institute is syncs for C#, or sorry, syncs for Scriven templates. So this is what we consider an abstract sync. So this is a sync that is intended to be implemented in your own software. And that is exemplified in the adapter. The transpiler for the adapter has a reference to the C# sync. Okay. If we look at the MTCup site, we'll see that we have Scriven templates, and then C# sync actually implements Scriven templates. It uses this abstract sync and another abstract sync to help you create a transpiler for writing C# code. These are all free and open. I know that there's a couple other development efforts happening outside of MTConnect. Whether or not those are open source, I'm not sure. If anybody else has their own implementations of custom syncs, we would love to, to be aware of those projects and make sure that they're referenced here. I think one example was in TrackHound. I found a reference to the transpiler for their MTConnect.net library. So with regards to the agent, we're waiting to use the transpiler in the agent. We're just waiting on developing a C++ sync to help us write those, write the code for C++. And then, you know, it should be pretty easy to implement that. Does that answer the question?
Yeah, I think that's good. The last question that had got sent in for you was, and you may have just answered this actually. Any plans to port to other languages?
Absolutely. Yep. So we are slowly but surely working on creating repositories for other languages. A lot of it's going to be based on the Scriven templates. We do, I don't think it's published, but there's a JSON schema repository that's similar to the C# one. We have immediate use cases for C++, but again, we've open sourced all of these libraries, so other people are more than welcome to reference this. If they have any questions on how to develop their own sync, feel free to reach out to me. And we're slowly building out a library of examples and documentation on how to do that yourself, so that if you have a unique use case, you can get started.